But the dinosaur was going to be the first space plane.
Wow.
Dinosaur. D-Y-N-A-S-O-A-R.
Oh, very good.
But then North American changed the concept and changed the name to the Challenger.
Wow.
So,
I think Boeing is talking about making a space plane again. Did you hear that? That they're considering a...
yeah, old Paul Allen's they're gonna build this huge aircraft to take a rocket up into space before they fire it, so it doesn't lose all its momentum.
Yeah. And it's going to be like a reusable thing, too. Like
Yeah,
it'll go
that's
up
in
and...
this morning's paper.
Yeah, I guess he's always been a fan of space travel, Paul Allen. He has always been interested in space travel, and he's always wanted to be involved in that kind of thing. So he's going into the private sector now, I think.
Yeah. That's going to cost a bundle of money. But he's got the money.
He's got the money.
They're talking about putting two 747s together.
Huh?
They're talking about putting two 747s together.
Like a double fuselage, and then the rocket is suspended in between them.
Yeah.
That's going to be the biggest plane ever flown.
They're doing a lot of things now that used to be just a gleam in somebody's eye.
Yeah.
You keep thinking that we're pioneering and coming up with things that are so revolutionary, and they've been thinking about these things for years.
Tell Gary about getting Boeing Wichita modernized and then being asked to come out to Boeing Seattle, and then how Boeing Seattle reacted to you coming out and all the nepotism that was going on.
Well, I was modernizing Wichita with numerical control machines, and the ratio of trade was about 3 conventional machines for 1 numerical machine. So we were getting high-tech machines, and it was requiring less tooling and less operators and less time, and the machine shop became almost all numerical control. It's the only one in the world like that. And we've been trying for 2 years to write software in 2-dimensional. I was Boeing Wichita's rep on Aviation Industries Association, and we were not successful in writing a 2-dimensional, and here we were coming up on a B-52 that required tapered skins 90 feet long, and machine tool people insisted on trying to have 180-foot rails and move the table like a planer, move it under a fixed gantry. And I was after a moving gantry with a 90-foot table, and the gantry moved up and down the 90-foot table. And the machine tool people said it couldn't be done. And I went to AMC and explained it to them. They had the money, and I got $248,000 from Bill North, who was controlled the purse strings at AMC, and put it out for bid, and the machine tool people wouldn't bid on it. Only one of them bid on it, and that was Onsford in Chicago. And they come up with a moving gantry. a very good machine. And there's only we only asked for a 48-foot table because what we were trying to prove that the moving gantry was feasible. Well, after we got the we got 100 A72C in the shop and got it running, didn't have tape control on it. We had a GE Amphidyne system on it, and we were going to later change that and make it a tape control machine. Well, the machine turned out real good. The gantry would operate within plus or minus 1,000, and it proved that the moving gantry could be built. Well, the Air Force for the B-52 had to have 90-foot tables because the skins were 90 feet long, and they tapered inboard to outboard, 5/8 inboard out to 5/16 outboard, and were scalloped here and there, and that was the Air Force money had to be allocated for those skin mills. Well, they put that out for bid, and Cincinnati bid on it and got the bid, and then they hired engineers from 100 to perfect it, and that became the skin mill that machined the skins for the B-52, the first skin-loaded airplane, and that proved very successful. But we didn't have any software, so I told the operation manager that we still need software, not 2-dimensional, but 3-dimensional. And I said, nobody is doing anything about that. So he made me chairman of a committee to write the software for 3-dimensional machining. And this was a production thing. We were faced with the producing skins within 2 years. So I set up a committee to and pick people. I could pick them from anywhere in the plant. I never will forget, we had a hippie type in finance, and he was a tremendous mathematician, and without him we could have never written the 3D software. But we did write 3D software, successful, and we took a different approach from what they had taken with the app program, the automatic program tool. Instead of having the programmer have to figure out each equation and solve it, we put the equations in the program so that it was a standard thing, that if you had certain points, you just asked for those and told the cutter to move in that direction and over those particular points, and the software solved the cutter center path. Well, it worked out real good, and our program was successful. The first 3-dimensional software ever, and we called it Waldo, Wichita Automatic Linear Data Output. And we made tapes, and when the machines came, the machine tool people couldn't even turn them on because they had no software. but we had software, and we had programmed for two skins, and we used a vacuum chuck to hold the skin down while we machined it, and we would machine two at a time, and it was very successful. And when Seattle, they were waiting on the app program, and it didn't appear, so we gave tapes to Seattle. Was based on the Wichita program, the Wichita software, and they got into production on it. But this was all pioneering and the moving gantry, the 3D software, the 90-foot tables was all the first in production, and we brought the big skin mills in. We used our software and our tapes and went into production on the skins. So Wichita was the first aircraft company to utilize the three-dimensional tapes. And then later on, we even had a method of proving a tape prior to ever cutting, so that we could send proven tapes to Seattle for their production. And that's the way the B-52 skin-loaded airplane got built.